Okay, so today on Modified Solutions, we're going to be taking a look at an AON unit on a rooftop of a bookstore. It's been raining water pretty much every summer for these people, just overflowing the drain pan whenever the trap stops up and causing them real fits and damage, lots of ceiling tile damage, floor damage, book damage, product merchandise, you name it, just a nightmare. And we're going to make this problem go away. But I don't want to interrupt the fan. I want the fan to continue to run in this air handling unit on the rooftop. And I want to interrupt the chilled water valve so that it cannot condensate anymore. And just do that with a simple float switch. But we're going to want to interrupt the correct. We want to verify that the chilled water valve returns to closed on normally closed. And make sure that we interrupt it correctly. And that we wind up getting a comm fail of sorts on the graphics on the front end workstation. So let's go forward and see what we've got. Okay, so here we are on the roof. We're going to be looking at these AON units, what we can do to keep these things from raining through the ceiling underneath. Looks like we got our condensate drain, our trap. Everything we need is all in one box. Kind of convenient. There's the drain pan. I'm going to be putting this float switch probably right along there. I use one of those screws. See how I can fit this thing. I really couldn't get the ultraviolet light in here. The chill water valve. So I'm going to be interrupting this sucker and running that wire probably along the same track as this one and just tying off to it. Use the same chase. It'll be a long run, so I'll use some 16 gauge 2 conductor plenum rated, instead of trying to run too much of the original wire that comes with the float switch because it's so much smaller. And we'll see what this does for us. Coming out of there, straight through this chase, and through this chase. And I'll be coming through that chase, following these wires up and across and through that chase up there to get to my drain pan. Coming through there, straight on down. I've got a real tight spot here that it just won't fit. But if I go this direction, I think I've got it. Just have a little bit of silicone I need to shave off that they put here on the edge of the drain pan. And I think that we'll have this. Let me get after it and try that. Okay, so this is the float switch. We're going to make sure that we put that nut in the slot on the one side of it so it doesn't try to turn. The back side is just for the bolt. So the bolt head has a small gasket. And we'll go ahead and I've got that cleaned up now where we can slip that on the edge of that pan. And this is the critical point right here where it always overflows. So this is the best location. We're going to go ahead and get this started. Okay. Go ahead and put this on here. have a normally closed and a normally open, but it's factory set for normally closed. So we should be in good shape. As long as the circuit we're interrupting is also normally closed. And I've already verified that it is, but we'll double check. Just going to tie it off to this coil for now. Give myself enough slack. I'm going to come straight up this. Right here at the float switch itself. I'll go ahead and get this started. These, I like to use crimp connectors for a better connection instead of wire nuts, but you can use wire nuts. I'm just going to go ahead and twine these. Doesn't matter which one you tie to, it's just a switch. That really good. Pull on the wires and make sure that they're not loose. They can't come out. We'll do the same thing with this one. Upward, and go ahead and go to the next compartment. And in this compartment, I'm just going to go ahead and continue running my wire across, following these wires along the most logical run. I put enough zip ties that it doesn't droop down, it stays nice and snug with the other wires. These are all control wires, they're low voltage. It's going to shock you because the power's on. If I was working in the blower compartment, obviously I'd have the power shut off. But I don't want to shut down the bookstore just because I'm putting in a float switch. That wouldn't make much sense. I'm just going to follow these wires right along here, keep going downward to the bottom, because that's where I'm going to cross over to my next compartment, not at the top, but down bottom. We're heading that direction to be able to make it to my ultimate chase. I like to push it from here, because if I go to the other side and start pulling on it, I'll have a tendency to tangle and cause a knot if I'm by myself working, which is most of the time. And you can also get hung up on something else. Just easier this way. Okay, and we're on to this compartment. I can go ahead and keep going. Come through this same chase over here that the other wires are going through. And then I'll land this in the shallow water valve compartment. So we've got the G and the Y. I'm going to take this G loose, see if that breaks and releases that valve. Okay, so we took G loose, and that returned the valve to its normally closed position. And we'll go ahead and wire up the float switch. Hear it opening the valve. And we're in business. It's open to its position that it was calling for. When it's all said and done, that's what it looks like. It's kind of neat. You're not a mess. Now I'm going to go ahead and test the float switch. I'm just going to prop that float up with my pliers where it should be in the open position. We'll go see what that valve does. And the valve went back to closed position. You can see the indicator all the way to the 0. That's closed. Now we'll take the pliers out and verify that it goes back. You can hear it driving that valve open. You can see the indicator going back to its position it's calling for. And it would appear that it works. We'll just make sure that we get a comm fail whenever that thing breaks. And then you'll notice it on the computer graphics. And you won't have to be told that it's getting warm in the store. You'll see it on your morning run through the graphics. Okay, so ultimately it was successful. We got the chill water valve to close when the float switch opened and water level rises. It kills the chill water valve. We got the fans still going. They still have air circulation in the bookstore. The only thing is, it will not give me a comm fail on the computer because the controller for everything is still telling the chill water valve to open, and that's fine. I just still have the graphics showing that it's telling it to go to 100% if it won't cool enough, and that indicates a problem right there. So with a trained eye, that's something you're going to catch anyways, or they're going to give you a little bit of a hot call here and there saying it's getting warm in here. As the water starts to subside in that pan, it will bring that chill water valve back on, and it'll just kind of go back and forth a little bit if it is draining at all. If not, if it's totally stopped up, it'll just sit there off until someone comes to unstop the drain. Okay, so if you like what you've seen or you have any questions, comments, anything, please write to us. Hit that like or subscribe button, and we'll talk to you on the next subject.